so the pressure was 28.5. Now we had 10 litres in 6.34 seconds average. So how many litres is that? Litres per second.
16.
You divide
10,
10 by 6.
6 point or 6,
6.34.
1.5.
1.57. So the Q equals 1.57.
What the Q stand for?
Flow.
Flow, yeah.
In engineering, flow is often, particularly in hydraulic engineering, flow is demarked by Q. So, our input power, we need to multiply the pressure, 28.5 metres, by 1.57 by acceleration due to gravity, 9.81. And that gives us
438.
how much?
400.
438.
1.5.
Okay.
What is the unit for input power?
Watts.
Unit watt.
Watts.
Watts,
It-
watts.
yeah, power is always watts,
Watts,
whether it's hydraulic, electrical, mechanical, power is always in watts. Okay, so that's our input power. Our output power. Now, you can see here that it varies with speed. Speed down here, and what's happening is that when the turbine is running at its fastest, we've got no output. And that's because the jet is going at the same speed as the outside of the wheel, and there's no transfer of energy effectively. Well, there is, but it's only enough to overcome friction and windage. It's not actually generating anything. When the wheel is almost stationary, i.e., 100 RPM, again, there's no transfer of energy because the turbine, our generator, is running at very low speed, so it's not generating any energy. Right, now roughly we're getting a peak at about 710, and we're getting a peak output power of 197 watts. That's output power. So what sort of efficiency are we getting? If our input power is 438 watts, our output power is 197 watts, what's the efficiency? For efficiency you measure power out divided by power in.
Wow.
So it's 438 divided by
0.1.
100 and
Other way round.
Yeah.
Power out divided by power in. So it's 197 divided by 438.
It's for 45%. So it's 0.5. It's almost the half.
Did I get that right way? Yeah. Power out in watts divided by power in. Is that point? You happy with that? 45%.
Okay, 45.
That's
Power out is the biggest watt, right?
I'll come into that in a minute. That's about 45%. Now, in relation to speed, that is at 710. Well, we're not exactly sure where it is. That's at the point we've got what's called the point of inflection of the curve. But at 900 it's 175, and at 490 it's 178. So if we were to draw a graph, which you've got to do in your workbook, and this is RPM, and we know that the fastest was 1300, and watts, we know the peak is somewhere around 200. We're not quite sure where. And if you take two readings above and below it, 900, say that is about here, and 490, which would be about a third, isn't it? So that's about there. We know that at 710, we know we've got a peak, but it's somewhere between those two, that in the middle. We get a curve that shapes something like that. Whoops, sorry. Now, I would expect the peak to be at about 650 RPM. And that's because the physics of it, if you worked out the maths and the physics of it, the speed of the turbine wheel at peak output would be about half the speed when it's at its faster speed. And that's because of this thing I explained earlier, that there's no power transfer here, because the jet is actually the same speed as the runner. At this point, when effectively the wheel or the runner is actually almost stationary, and you can prove it mathematically that the relationship, the maximum power transfer on that type of turbine, the Pelton turbine, is when the peripheral speed of the wheel is half the speed of the jet. And that our experimental results more or less bear that out. I'd expect that to come at about 750, and our maximum efficiency is about 45%, which for a machine like this I would expect. If it was for instance, if you look at the turbine in the display, which is a really good, well-built, well-engineered turbine, I'd expect that to be a bit higher. I'd expect that to be about 55 to 60. But on this machine, for various reasons, it's a little bit lower. I should take a picture of these results because you're going to need to put them into your workbooks.
So the output power is the biggest watt, right?
Sorry?
The biggest watt.
That comes at 7. Yeah, that's about halfway across the speed range. It comes at about 700.
Him is the one that we used here.
Yeah, you
Use the highest one.
use the highest one. That I think that actually should be more like 200. That would be a little bit higher, maybe 200. But it's very difficult to actually get that experimentally. You'd have to take so many results. Okay.